Dear students, good morning. Let us continue lesson 3, metals and non-metals. In our last class, we have already discussed physical properties of metals. And today we are going to learn chemical properties of metals. The first one, what will happen when metals burn in air? Okay. Chemical properties of metals. Okay students, we can start. What happens when metals are burned in air? In the first chapter, we have seen that magnesium burns with air and gives a white color. Okay, and it forms magnesium oxide. Now we can check that do all metals burn in air? Okay. The question is what happens when metal combine with oxygen? Metal plus oxygen gives metal oxide. For example, copper plus oxygen gives copper oxide. Now we can balance this equation and we will get 2Cu plus O2 gives 2CuO. And the next one is aluminium plus oxygen and we will get aluminium oxide. Here also we can balance this equation. How we will get that aluminium oxide equation that we have already studied in 9th standard, and we will get the aluminium oxide as Al2O3, and now we are balancing this equation. And we got 4Al plus 3O2 gives 2Al2O3. Here metal combines with oxygen gives metal oxide. Now we already discussed two examples, copper plus aluminium. In both cases we got their oxides. That is copper oxide and aluminium oxide. Next, we have to check the nature of metal oxide. This experiment we have already did in 9th standard, and we got that magnesium oxide dissolved in water and they change red litmus blue. That means metal oxides are basic in nature. But here we have to check that do all metal oxides are basic in nature? No. Some metal oxides are amphoteric in nature. Okay. Now we can discuss basic nature and amphoteric nature. Basic nature examples we can see. They will change red litmus to blue. Example we have already discussed magnesium oxide. And another example is sodium, potassium, etc. All these metal oxides are basic in nature. But some others are amphoteric in nature. For example, aluminium oxide and zinc oxides. Very important one. So, what do you mean by amphoteric oxides? Amphoteric oxide, that means these metal oxides react with acid and base. They will react both acids and base and they will give products as salt plus water. In both cases, that metal oxide react with acid and base. In both cases, we will get salt plus water. Examples, aluminium oxide and zinc oxide. Okay. Now we can check how they will react with the acids and bases. First, we can take aluminium oxide. As acid, we can take HCl, and base, we can take sodium hydroxide. Okay. And we know that the products are salt plus water. So the equation for water we can write first, and we can write, now we can write salt. Okay. We will get aluminium chloride, and we have to write its valencies and interchange, and we will get the chemical formula as AlCl3, and after that we have to balance it. Okay, then we will get, now aluminium is balanced, next we have to balance hydrogen, and now we got the equation as Al2O3 plus HCl. That means we have to balance it, and we will get Al2O3 plus 6HCl gives 2AlCl3 plus 3H2O. It's very important equation. The next one, how it will react with the sodium hydroxide. Here also we know that the first product is water, so that we have already wrote it. The next one, we have to write the equation for its salt. Okay, so Al, Na, and salt also contain oxygen, that is O. AlNaO. So we have to rearrange it, and we will get the formula for the salt is NaAlO2. NaAlO2, and we have to balance it. Okay. So we will get the equation as, here we know that aluminium 2, but here only 1. So we have to balance it. So we have to write 2 there. And the equation is Al2O3 plus 2NaOH gives 2NaAlO2 plus H2O. In both conditions, aluminium oxide react with the acid and base and gives salt plus water. This is called amphoteric oxide. Amphoteric oxide means they will react with the acid and base and give salt plus water. Then next question is, metal oxides are soluble in water. We have already did this experiment. Magnesium oxide, to the magnesium oxide we have to add water, and it turns red litmus blue. That means some metal oxides are soluble in water, but some other insoluble in water. So metal oxides which are soluble in water are called alkali. That is, sodium oxide dissolve in water and gives NaOH. NaOH is alkali. The next one is potassium oxide, also dissolve in water and give KOH. So these sodium oxide and potassium oxide dissolve in water and we will get alkali. So metal oxide soluble in water, that are called alkali. Insoluble metal oxides, for example magnesium oxide, when we dissolve the magnesium oxide in water, we can see that the full magnesium oxide or that fully ash will not soluble in water. So some metal oxides are soluble in water, that is NaOH, KOH, etc. But some other metal oxides are not soluble in water. For example, magnesium oxide, the ash will not soluble in water. Sometimes it will soluble in water and gives that red litmus turn blue, but the ash will not dissolve completely in water. The next one, do all metals react with the oxygen at same rate? No. Here we can see that a series of metals, and this order, this is known as reactivity series, that we will study next class. Okay. So here we can see that the arrangement of metals. Here also the first metal is potassium. The next one is sodium, calcium, magnesium, aluminum, etc. The first two metals, potassium and sodium, when we are kept open, they will catch fire easily. That is why this potassium and sodium are kept in kerosene. Okay, when they kept open, they will catch fire. That means they will react with the oxygen very fast. That or we can say that vigorous reaction. So always they will kept in kerosene. Otherwise, we can see that there is a coating of wax for these potassium and sodium. All these wax covering, and when we are keep them in kerosene, we are protecting them from the reaction with the oxygen. So there is a important question, why we are keeping this sodium and potassium in kerosene. It's very important one. We are keeping in kerosene, otherwise there is a covering of wax. Otherwise it will catch fire easily. So potassium and sodium react with the oxygen very fast. The next one we can discuss magnesium and aluminium. When we are keeping this magnesium and aluminium, they forms a covering. We already seen in magnesium, isn't it? A covering of magnesium oxide will be there. That covering of magnesium oxide or aluminium oxide prevent them further corrosion or further reaction with the oxygen. Okay, so first they react with the oxygen and a covering will be there, magnesium oxides cover or aluminum oxides cover, and it prevent them further oxidation. Okay, so the next one is iron. Actually, the reaction of iron with oxygen is very slow, but iron fillings, we know that what is iron fillings, it's a powder. Okay, so these iron fillings react with the oxygen very fast. Okay, it's a powdered iron. Okay, it will react with the oxygen very fast. And the next one is copper. Copper react with the oxygen. We can see that a black covering, that is copper oxide. Copper oxide is black in color. So a black covering will be there on the surface of copper. And the next one is silver and gold. They will not react with the oxygen. So we can keep them outside for a long time. Okay, so the reaction of metals with the oxygen is not same. So here we already in this chapter, in this topic, we have already studied that metal react with oxygen for metal oxide and their nature. Some metal oxides are basic in nature and some other metal oxides are amphoteric in nature. And examples, very important one, aluminum oxide and zinc oxide. Then next one, their solubility. Some metal oxides soluble in water and form alkali. For example, sodium oxide and potassium oxide, and they will give their hydroxide. But some other insoluble in water. Then the next one is reactivity. That means the reaction of metals with oxygen is not same in all metals. First, sodium and potassium, vigorous reaction. Magnesium, aluminum, a covering will be there. And iron, the iron fillings react with very fast. And copper forms a black coating. And the last one, silver and gold do not react with the oxygen. Read page number 41 and 42 and study well. If you have any doubt, please call me. Thank you all.